we start with a definition of the word percent. So whenever we see this word, we always understand actually two words by it. Two words, per and cent. The word per is, we know this word per in everyday English, right? So a car consumes 8 liters per 100 kilometers, for example. So this per means for each. What does cent mean? The word cent is frequently met in some other word, for example, century. Cent means 100. So century is 100 years. So we have cent is 100. Which means that the word percent means for each 100. We can use this definition of the word percent to solve problems. But before we do that, you always need to keep in mind that this word percent for short is written using this symbol percent. Just like the word dollar uses symbol dollar. Whenever we see the word percent, we can replace it by the symbol percent, and whenever we see symbol percent, we can replace by the word percent. That will be very important when we solve our problems. Let's start with the first problem, which is a very easy problem. So this problem will be find 20% of $400. Well, this symbol percent means word percent, which is per 100. So what this phrase means, it means that take 20 per 100 given 400. So you're given 400, which is 4 hundredths, 100, 100, 100, and 100. You are given 4 hundredths. And we'll take 20 out of each 100, right? So 20 from here, 20 from here, 20 from here, 20 from here. In total, so if you connect all these 20, 20, 20, 20, you get 80, right? So in total, it is 80. Therefore, 20% of 400 is, so answer is $80. So here we used only the definition of percent in a straightforward way, which is per 100. We can actually now make that problem a little bit more complicated. So we'll say find 20% of some quantity such as 2.93, like this. Right, that can be $2.93. Well, in this case, it's harder to use that straightforward definition of the word percent. Why? Because 2.93 is not given to us as a quantity of hundreds. At least it's not given to us as readily as a quantity of hundreds. We can imagine it to be quantity of 100 smaller pieces, right? So not hundreds of dollars. But it is still much more helpful to replace the notion of percent as quantity per 100 by the quantity per one. So what I mean by this is 20% of an amount is 20 per each 100, right? So 20% of an amount is 20 per each 100 of the amount. But all this and this is the same as, and this is the same as 0.2 per each $1 of the amount. So 20% of an amount is 20 per each 100 of the amount. And this is the same as 0.2 per each $1 of the amount. Okay? When we, in financial mathematics, when we speak about amounts, we always mean amount of dollars. Well, once again, just to simplify this phrase, so $20 per $100 is the same as $0.2, which is 20 cents per $1, right? So when we speak about this type of quantity, that is percent, as we already know. But when we speak about this type of quantity, that is measurement per each one, so this is going to be rate per one. Rate per one. Keep in mind that I can write symbol percent here instead of the word percent. But here, no, I cannot write symbol percent instead of rate per one, because rate per one is rate per one, not rate per 100. Now, why is it such a helpful concept to have rate per one instead of percent? The reason it is so helpful is because any amount is the amount of ones, right? So any amount is always the amount of ones. And we can find a percentage quite easily by taking the number of ones and multiplying by the rate per one. So in this case, it's 0.2. Right? So I have number of ones, 2.93 ones, and I multiply by the rate per one, and I will be getting my result. So 2.93 times 0.2, 0.586 is my answer. Well, because we're talking here about amounts in dollars, 0.586 is rounded, so this curly equal sign I will be using for rounding, so it's 0.59, 59 cents. Okay, let's have a little bit more complicated problem right now. So I can say that let's find 0.05% of So find 0.05% of 3,776. You see, we have symbol percent here, and we also have 3,776 ones. So we have 3,776 ones. We multiply by 0.05 divided by 100. Now, why did I do this? Because I noticed that there is symbol percent here. This symbol percent means quantity per 100. I replace that quantity per 100 by quantity per 1. How do I do this? By dividing by 100, right? So whatever is quantity per 100, if I divide that quantity by 100, I'll get quantity per 1. And 0.05 divided by 100 multiplied by the base, that will be 3,776 multiplied by 0.0005. You see 3 zeros here because I just add 2 zeros after I divided by 100. The result is 1.888. If I round that, it's going to be 89, right? 1.89. If I round to 2 decimals. But keep in mind that various problems will ask you rounding for various number of decimals. In this case, I round to 2 decimals. But if the problem said round to 1 decimal, it would be 1.9, and so on. Now, in this problem, something to really keep in mind is that a lot of students make mistake here. Because, you see, especially if students already have solved a bunch of problems using percent, these students, when they see 0.05%, for some reason they automatically begin to think that they are given already percent, 5%, instead of 0.05%. So basically they ignore this percent symbol. Incorrect solution then would be like this: 3,776 multiplied by 0.05, right? Many people would solve this problem like that. They would multiply by 0.05. Why? Because for some reason they would begin to think that already they are given 5%, and already they are given this decimal or rate per one for that 5%. But that's not the case. You should never ignore this symbol percent. If you see that symbol percent, it's quantity per 100, even though that quantity can be very tempting to use as already converted percent. Our next problem will be finding percent. So what percent is 6.3 of 76.4. So what percent is 6.3 of 76.4? Well, we don't know percent, right? Remember that percent is quantity per 100. And I have 76.4 ones. So 76.4 ones. Let me multiply that by some rate R, and that is rate per one. I'll find percent later, which is I'll find quantity per 100 later. For now, I multiply by R small, and that R small is rate per one. I have 76.4 ones. Multiply by rate per one, and you get 6.3 as the result. So R is 6.3 divided by 76.4. 6.3 divided by 76.4. So you have 0.082460733. R big, which is actual percent, because look, in this problem we're asked for percent, right? And R big is taking this rate per one and multiplying by 100. So this is R, rate per one, which I'll multiply by 100, and as a result it will be 8. See, I just moved to two places, so it's going to be 8.25%. And now I can use this symbol percent. I have the complete right to do this because I found a rate per 100, which is percent. Of course, you could have solved this problem a little bit differently. You could just say, okay, 76.4 multiplied by rate per 100 divided by 100 equals to 6.3. So in this case, what you do is you try to find percent right away, which is pretty much the same thing. It's just a little bit algebraically maybe more complicated solution. So here you will have R big is 6.3 times 100 divided by 76.4, right? And the answer will be, of course, the same. But I prefer solving with rate per one in mind, because that's how we solve almost every problem in business and financial mathematics. We always use rate per one. Okay, let's just now consider another problem, and which is this. Let's say 0.6% of what amount? 0.6% of what amount is $755. In this problem, we don't know B, which we call base amount. So we don't know the number of ones. We have this base amount multiplied by 0.006, right? And what is this? 0.006 is rate per one corresponding to 0.6%, and we have 755. So B is 755 divided by 0.006. Now what we do is we take 755 and divide by 0.006. The answer is 125,833.33, rounded to 2 decimals. By the way, it is always helpful to double check your work if you want to make sure that you are making the right solution. So 125,833.33, multiply that by 0.006, right? And that should give you 755. Now you just can always double check that. Right, 755 is the result. That's the way to go. Every time you solve a problem, it doesn't hurt to check, just going backwards in that solution to make sure that you're right. Let's consider now finding 103% of a number. So if I say find 103% of 275, okay? Of course, we'll find this regular way, 275 times 1.03. So 1.03 is the rate per one corresponding to 103%. Now let's just solve this. 275 times 1.03 is going to be 283.25, right? So the same process. However, why this process is so important is because in future in our course we will encounter a lot of calculations which involve percent which is higher than 100%, right? One thing in particular for you to keep in mind that I can actually write this quantity like this, of course, right? So 1 plus 0.03, which is the same as 1.03. Now, why I write it exactly this way, you will learn later on. You will learn more about it later on. But what this represents is that it's 100% here, and 1 stands for 100%. 1 is the rate per one, which corresponds to 100%, and 0.03 is the rate per one, which corresponds to 3%, right? So 103% then is 100% and 3%, but written in the rate per one, it's 1 plus 0.03%. Just even though it looks like a very obvious stuff that I'm talking about right now, trust me, in future, you will see this a lot. And sometimes students are getting confused eventually. Why is it that we always write like this, 1 plus some number, right? And we do that because in financial mathematics, there is a lot of percent calculations which involve 100 and something percent. And formulas also will reflect the same idea. in formulas you will see 1 plus r, 1 plus I, 1 plus something else, and that is the idea which starts here. Okay, so for now just just absorb this very simple idea that 1.03 I can write as 1 plus 0.03. It's extremely simple, very obvious, but just pay attention to that at this moment, because later on you will see how we will be making a use of that. Consider this situation. Okay, so you have some $100. Now this $100 is being increased by let's say 10%. Okay, and then it will become some amount which we will be talking about later, and then whatever that becomes, it will be decreased by, so it's increase, here decrease. And then it will become some amount. Okay. So in this situation, we take $100, increase it by 10%, and then decrease it by 10%. And if I were asking you right now what amount it will come to, if you don't think too deeply about that, and if you just rush to your answer, chances are that you will answer it will be back $100. But that's not right. Okay, so when you talk about increasing by or decreasing by percent, you need to be careful. If I told you about this problem in a different way, if I said that let's increase $100 by $10 and then let's decrease that amount by $10, so of course you will end up with $100, because $100 plus $10 is $110, and then if you decrease that by $10, it's back $100. But if I increase by percent, situation is different. So if I take $100, increase it by 10%, it will become $110. Now, we'll speak more about increase just shortly, but now you probably can already understand what it means increasing by 10%. So increasing by 10%, you put 10% on top of original amount, right? So 10% of $100 is by definition 10, right? And putting $10 on top of $100 makes $110. That's the increase by 10%. But then when you decrease by 10%, what you're doing is you're taking 10% from 110, and that means you're taking $11, right? Because 10% of 110 is 11, and if you take $11 off from $110, you will end up with 99, right? So as you can see, when what this problem shows is that percent behaves differently from just adding amounts, subtracting amounts, and that is something really important for many applications in business and finance. Now, after basically this introduction and this example, and after you realizing that when you're increasing and decreasing by some percent, you have to be careful about what is going on, and there is a big difference here from adding and subtracting amounts. Now we will proceed and really investigate what increase by percent and what decrease by percent means, and also we'll talk about some important techniques in problem solving. So let's return to that original example that just now I showed you, but now let's first speak about increase. So we'll dig deeper into that example and we'll discuss how really you will compute stuff, right? So let's write this problem separately here. So increase by 10%, okay? Increase by 10%. And let's say original amount will be $100, right? So start with $100 and increase by 10%. Now, as I already told you, increasing means adding, finding 10% and adding on top of that amount, right? So basically, first thing that everybody would do to solve this problem, 99.9% of people would solve this problem as a two-step process, right? So they will be solving like that. It's a two-step process. First step is this, 10% of 100 is of course $10. And second step, you take 100 plus 10, which is 110, right? So there is a two-step process involved here. And that's what it means to increase by 10%. Now, once again, if I gave this problem to almost everybody, and because our brain works that way, we always will go through that two-step process to solve that problem. However, that two-step process is not really very good when you want to solve complicated problems. Okay, I'll explain you why. Let me modify this problem a little bit, and I say start with $100, increase by 10%, 20 times. Okay. So in other words, I want you to go into a compound process. So every time you increase by 10%, you need to take that new amount and increase by 10% again, and increase by 10% again, and again, and again. So this process will look like this. So you start with 100, then you increase, then you increase, then you increase later. It will be eventually exponential growth, as we say, but you will realize that 100 will become 110, 110 will become 121, and so it will go 20 times, right? So if you were to solve this problem by using that two-step technique, what would you do? You would have to execute two steps first, and then you will find 110, right? So then you will have to do that two-step process again, and then you will find 121, and again, and again, and again, and again. So it will take you 40 steps really to solve that problem, right? 2 steps per each stage of the process. So, but in total, it's 40 steps. Definitely very inconvenient, especially if I now replace this 20 times by, let's say, 365 times, because it might be that your stock, which starts with $100, grows for 365 days in a row, right? So it will be very, very laborious and sometimes even impossible when we have a lot of increases happening one after another. Therefore, it is much better to adopt a completely different way of thinking. And that way of thinking will be something major for our problem solving in future. So what way of thinking I'm talking about here? So look, we already kind of encountered that when we talked about finding percent which is higher than 100%. So when I increasing by 10% is the same as finding 110% of the amount. So increasing an amount by 10% is the same as finding 110% of the amount, right? Think about it. So if you increase something by 10%, right? So it is the same as 110% of that amount. Well, what is decreasing by 10%? So it's increasing by 10%, right? But what is decreasing by 10%? Well, decreasing by 10% is the same as finding 90% of the original amount, right? So, for example, you come to a store, if you see some product is $100, and if it is a discount 10%, so if that amount is decreased by 10%, it is the same as that you pay 90% of the price, right? Okay, so increasing by 10% is the same as finding 110% of the amount. And what that really means, that means that you start with $100, then you will find 1.1, you will multiply by 1.1, which is rate per one for 110%, right? So what you just did, you increased $100 by 10%. So you increased $100 by 10%. In other words, you found 110% of $100. But that happened once, right? So that becomes your new amount, which is $110. Then you will multiply by 1.1 again, 1.1, and so it will go. 20 times, right? So when we multiply the same amount by itself many times, we actually have exponent. So if you take that 1.1 multiply 20 times, you get 1.1 exponent 20. In mathematics, we sometimes don't write multiplication sign when it is clear that there is multiplication there, right? So I remove this multiplication sign, and sometimes I'll do that. Sometimes I will write multiplication sign explicitly when there is a possibility of confusion, but here it's not necessary. So I'll find exponent now. 1.1 exponent 20 times 100, right? So the answer is 672.75. You see, I want you to appreciate something really deeply right now. I found the answer by just computing one line, okay? And what that, how it was possible is that I simply replaced the two-step process, which is a more natural kind of process to think about, by a one-step process in finding percent increase at each step. And that one-step process is finding 110% of the original amount instead of putting 10% on top of the previous amount. You see, that allowed me to write this exponent here, okay? Now, I just want to write this a little bit differently, something which I already kind of began to foster, began to explain you before. So you can write this as 1 plus 0.0, 1 plus 0.1, right? 20, like this. So again, 1 plus 0.1 means that 100% was in the beginning, and then you put 10% on top of 100%. So 1 plus 0.1 means 110% you're finding here. Again, something obvious, which I did, but in future you will see how in our formulas we will behave in this, we will have this idea. Okay, let's consider this problem now. Find 574.19 increased by 6%. Well, remember that idea that instead of me finding 6% now of this amount and then putting on top of that amount, instead of that, I'll be finding 106% of that original amount, because increasing an amount by 6% is the same as finding 106% of that amount. So let me write this idea in this way. So the answer to this problem will be 574.19, 1 plus 0.06. You see, I already will start writing in this way because I already explained it many times, I think, before. Why I'm doing this 1 plus 0.06? Again, that stands for 106% of the amount, but I will be, writing 1 plus 0.06 rather than 1.06 every time, so that you get used to the way our formulas will be structured around this idea. Okay, so if I increase this amount by 6%, I find 106% of that amount, and let's compute this. $608.64 rounded to 2 decimal places. All right, so that's how we use that idea of finding 100 and something percent instead of adding percent on top in a problem which involves more or less non-obvious numbers. Okay, so now let me just put it all in a formula. Okay, let's say we can speak about the original amount that we are increasing as VI. So this stands for value initial, right? So value initial. So your starting value. And then let's talk about VF, which is value final. Okay? Or it can be initial value, final value. The reason why I use the value initial and initial after value is because the subscript is after V. Okay, so you have value initial and then you have value final. So now, how do you get final value? Is you take your initial value and increase it by some percent R, right? And that's a rate per 1, of course, right? So you increase it by some percent R big, which is your percent rate per 100, but in the formula I put it like this: 1 plus R small, where R is the rate per 1 corresponding to a percent increase. So 1 plus R here stands for 100 and something percent of initial value, and that represents a percent increase. So this is how your formula will look like for finding your final value. That's actually what we just did now when we solved a problem just before. Okay, so now I want, even though this, if you understand how this formula works, still it's helpful just to put it in one general idea involving just abstract letters, so that you can see how this idea can be written in a formula. But let's solve this next problem now. Next problem is this. Problem so product after tax is 748. What is the price before tax? What is the price before tax? We assume that tax is 13%. So product after tax is 748. What is the price before tax? Now, I'll tell you that in this problem a lot of people make mistake. Why? Because what a lot of people would do, they would subtract 13% from 748, right? So they would basically go from the final value and go back to initial value. But in reality, that is a mistake. That's a confusing initial value and final value. So the correct solution is to notice that we actually don't know the initial value, the value that has been increased by 13%. So we don't know value initial, 1 plus 1.13, you see? So that's what I mean by increasing by 13%. I find 113% of initial value, and I will be getting my final value, which is 748, right? So now I need to find my initial value, and that will be 748 divided by 1.13. So here I already can write 1.13 because now I made my point by showing by being aligned with the way our formulas are, but now it's just a computation. So $661.95 rounded to 2 decimal places. Now you can check, right? So it's always helpful to check. So you have 661.95, 1 plus 0.13. So you take 661, that original price, increase it by 13%, and of course you should be getting your 748. Let's see what happens. 661.95 times 1.13. You have 748. In fact, you have 0.00. So you have 0.0035, but this extra decimals here are because we rounded initial value, right? So if we remember about that rounding and its effect, we should not worry about that decimal which is appearing here. So this check really showed to us that we did compute this initial amount correctly. Once again, I want to stress that incorrect solution, incorrect, is to take 748 and basically decrease it by 13%. So what is the percent increase that makes 475 grow to 493? So what is the percent increase that makes 475 grow to 493? So in this case, we do not know percent increase. Well, we already need to recognize that 475 is our initial value, 493 is our final value, right? So we now have 475, 1 plus r, so we don't know the rate per 1, which allows 475 to be increased to 493, so we put it as r, and it's going to be 493, right? So how do we find this r? So first of all, we need to find 1 plus r, that's going to be 493 divided by 475. So this arrow means next step, basically, so that I don't have to continue going to the bottom. So arrow means next step. So how do we find this next step? We just move this r to another side. So 493 divided by 475 minus 1. Okay, so let's calculate this. Zero point 0.03789.5. Okay, so I will round at that moment right now because that's enough for me, and that's a rate per 1 I found. You need r, right? You need percent increase. Remember, the problem is asking for percent, right? Which is rate per 100. So you need to multiply this rate per 1 by 100. So you move here, right? So your answer is, if rounded to two decimals, it's going to be 3.79%. 3.79%. Look, so if it's 3.789, because it's 9, 8 becomes 9, so 3.79% is the answer. Okay. Well, if you know just a little bit of algebra, you can deduct a formula from here for percent increase. And that is the formula that you can use if you want to calculate your percent increase right away, if you want to avoid like extra algebra. So this problem, this formula can be obtained this way: VI 1 plus R, right, equals VF. Okay, so basically you have seen that it's 1 plus R is VF divided by VI. Okay, so from here R is VF divided by VI minus 1. Okay, now if you make this last calculation here, you'll see it's going to be VF minus VI divided by VI. You just found, common denominator here, and that's in terms of rate per 1. So you take your final value minus initial value divided by initial value. But in fact, in this formula, you can notice something interesting, right? So you can notice that what on top you find is that its amount increased, right? So VF minus VI is the amount that has been added on top of VI, and then you divide by VI as your base. So you found that amount increased and then you calculate what percent that is if your base is VI, right? So that's what that formula means. But now, also, if you want to put this formula is in terms of percent change. So now, if I want, to call this percent increase percent change, so then I can multiply this by 100, and that will give me that percent change. This stands for percent change. By the way, this is a universal formula, which means that if you have a decrease, you can still use it, but the answer will be negative for decrease, and that negative answer means that that change is actually decrease, not increase. Okay, but we'll see this in some other problems. Okay, so this formula is something you can use if you want to find percent change just in one shot using the formula. For our next problem, we'll be finding percent decrease of an amount, percent decrease itself. Okay, so for example, 723 became $700. Okay, what was percent decrease? What was percent decrease? Well, we can use this idea that you have some initial value. In this case, initial value is 723, right? So you start with the initial value, decrease it by some percent you don't know, and then you will get your $700, right? So that's initial value 723, 700 is the final value. We need to find R. So how do we do it? 1 minus r is 700 divided by 723. Now we will be finding r. And r is 1 minus 700 divided by 723. Perfect. So let's calculate that. So the answer is r is 0.0318. If it's a rounded value, but it's rounded enough for us to say that it's 3.18%. That's 3.18%. Decrease, 3.18% decrease. Now we will try to solve this problem in another way so that you can see how various ways are connected. It's basically the same idea but using different approaches. So now another way to solve this will be this. We can essentially say that amount of decrease is $23, right? Because essentially that is 723 minus 700, and it's $23. So now you find, it was your first step to find that amount of decrease. But the second step is to find that amount is what percent of the initial value. And that will be it will give you percent decrease. So 23 divided by 723, of course it will be the same value, but you can check, right? So 23 divided by 723, always check yourself, it's 3.18% again. And that's percent decrease. Now there is another way to solve this problem, and that will be simply using the formula. Well, you remember the formula that I gave earlier? It's a percent change is VF minus VI divided by VI times 100%. So this formula allows you to find percent change without using too much algebra. But remember, in this formula you have this percent change, right? So this formula does not really tell you, this formula is not specific for increase or decrease. This is just for any kind of percent change. So when you use this formula, you have to be very careful to plug correct values in the correct places. So in this case, you have final value. What is your final value? It's 700, right? 700 is the final value. Initial value is 723. And then you divide by initial value, which is 723. Now note it, and then multiply by 100. Right? So notice that you will actually have negative number here. Minus 23 divided by 723. So you will see negative value, right? Times 100%. So this negative value, I'll just write it this way. This negative value means that you are dealing with percent decrease, right? So this formula is for percent change. It's neutral. When you use this formula, you can use it for either percent increase or decrease. And when your answer is negative, it implies that your result is decrease. And when the result is positive, the result is increase. Again, you can practice calculating every time, right? So, by the way, using different ways to solve things is a good, surefire way to check if your calculation is always right. So when, especially on a test, you can solve the problem in two ways, right? So you can calculate with one way and then check yourself with another way. And then you will be basically confident that you are giving the right answer. Our final problem for this class will be this, which will kind of put several things together. So we'll say stock price increased by 14%, and then decreased by 14%. So by what percent, or what was the percent change? What was the overall percent change? So we know that the stock price increased by 14% and then decreased by 14%, but we don't know overall, did it get decrease or did it get increase? Okay. Now, how do we solve this? Well, let's just explore what happens for each $1 of that stock price. I think for many of our problems that will be a very powerful technique. When you're not given some initial amount to work with, you can basically always operate with $1 of that amount, because any amount is made of dollars, right? And you can say per $1 of price, right? So let's see what happens per $1 of the price, okay, of the stock. Per $1 of the price of the stock. Well, let me just, to save space, now I'll remove this phrase, and we keep in mind we're doing it per $1 of the price. So $1 is increased by 14%, so 1 plus 0.14, and then whatever it became, it got decreased 14%. Let's find what it results in. So 0.9804. Right? So $1 is now $0.9804, even though you're compelled kind of to round this to 2 decimals, but we'll not do that because it's not the final answer yet, right? So it's almost always we never round in the middle of the solution, okay? So now we have initial value $1, so VI is our $1, right? And VF, final value, what it became is $0.9804, right? I need to find percent change. So this, let's use a formula this time. So percent change. Your final value, which is 0.9804 minus 1. So your final value minus your initial value divided by your initial value divided by 1 times 100. So what is that? Okay, it's minus 1.96%. And what this minus means? Minus means that the amount has been decreased by 1.96%. what you can see in this problem is that increasing an amount by 14% and then decreasing the same amount by 14% is the same as decreasing the amount by 1.96%. So that's one of the possible ways to solve this problem. Okay, I leave it up to you to practice maybe with some algebra way as well to solve it. So we use the formula way, but you can basically use algebra way. But even without the formula, there is even some straightforward analysis you can actually execute. Basically, you can see that initial value became $1 became 0.9804. So right away you can see in terms of rate per one what change it is. So you can see it's a negative change because $1 became a smaller amount. And also you can right away deduce it's 1.96% decrease because you can see it as a rate per one right away. Okay. Well, there are various ways to really approach this. I leave it up to you to practice with this, and you will have some homework to do. In that homework, you will practice with a lot of problems of similar kind, more or less complicated, but it's very important to go about your homework in a very careful way. Okay, and your questions will be answered during our Q&A session. So you need to listen to our lectures for this week very carefully. If you still have questions, if something is not clear in my explanation or something you encountered in your homework which kind of make you confused, please ask those questions during our Q&As, and then I will be able to respond to you. Okay, so bye for now.